Hello friends, I welcome to all of you to OnlyIAS. In our Udan 500 plus series for prelims 2023, today we would be discussing about the geography and disaster management related topics. So topic of our day is geographical phenomena in news. So first topic is Fujiwhara Effect. So recently Typhoon Hinamanor, this was seen in two countries, South Korea and Japan. In these countries, typhoon was seen and it showed the Fujiwhara effect. So now question arises, what is Fujiwhara effect? Simply Fujiwhara effect देखो कैसे हो रहा है. Simply there are presence of two tropical storms, right? They are present over the same ocean. This is another condition. Both these storms are occurring at the same time. Second condition. After that, what is happening? These two tropical storms are interacting with each other. Also another condition is distance between the eye of one tropical storm and eye of second tropical storm, it has to be less than 1400 kilometer. So now under these conditions, two tropical storms will interact with each other and this will lead to Fujiwhara effect. So this is the interaction between tropical storms. Alright. So now what next question arises, what is the impact of Fujiwhara effect? So impact, now there are two tropical storm 1, tropical storm 2. Now what can happen in either of the tropical storm or both of the tropical storm? There might be changes in track or intensity of the tropical storm. Or what may happen, these two tropical storm may merge and form one tropical storm, bigger storm. So this Fujiwhara effect actually was identified by Japanese meteorologist Sakui Fujiwara. So this is all you need to know about Fujiwhara effect. Alright, let's have a look at the previous year question. It was asked in 2020. It was related to cyclones. And since we know Fujiwhara effect is associated with cyclones, so it is very high chance that UPSC may ask question on Fujiwhara effect also. Okay, so I'll give you 10 seconds. You can pause the videos. Please have a look at the question and then I will discuss the answer for the question. Alright, let's have the question. Look at the question. Okay, first question it says jet streams occur in the northern hemisphere only. We know jet streams occur in both the hemisphere. First statement is wrong. Only some cyclones develop an eye. This is a true statement because there are two types of cyclones, tropical, temperate cyclones. Tropical cyclones have eye but not temperate cyclones. So second statement is correct. We know first is wrong, so option A goes wrong. But second is correct. So B and C, either of these could be the answer. Okay. Temperature inside the eye of a cyclone is nearly 10 degrees lesser than that of the surrounding. We know how tropical cyclone looks, eye, and it is surrounded by the rain bands. So we know over here in the rain bands there heavy rainfall. So when rainfall occurs, there is low temperature. So temperature of eye would be higher. Not lesser, it would be higher. So third statement is also wrong. So answer C. C is the correct answer. I hope everyone got the answer right. Okay, let's move ahead. C is the answer. Okay. So next topic is rainbow. So recently what has happened, there has been a research study. According to it, mean annual global rainbow days. Like a rainbow occurs in few days. But now what is happening? Throughout the year, number of days on which rainbow is occurring is increasing. So mean global annual rainbow days are increasing. And what is the reason behind it? Because of global warming. It is caused by greenhouse gas. So because of this, what is happening? There is changes in cloud cover and also precipitation. And these are we need cloud, precipitation and sunlight. These are the basic elements we need to form the rainbows. So if climate change is affecting the amount of cloud cover and precipitation, this is leading to change in the rainbow days also. Okay. So now what is rainbow? It is an optical phenomena. It is a multicolored arc you must have seen. We have 7 colors. In short form we say Vibgyor, violet, indigo, blue, green, yellow, orange, red, right? And how it forms? Through refraction of water droplets by sunlight. So sunlight and rainfall are essential, and itself research says liquid precipitation is getting changed. Alright. So now let's have a look at basic how rainbow is formed. See, sunlight is forming. This is raindrop. At the edge of the raindrop, what is happening? Light gets refracted. So at the edge, refraction takes place. Refraction simply means when there is a change in the medium. Suppose there is A medium, B medium. If sunlight is moving from A medium to B medium, but we know density of the B medium is different. So light will not move straight, rather it will get bent. So bending of light due to change in the medium, density of the medium. That is refraction. Now once light enters the bubble of the water, what would happen? There would be the phenomenon of total internal reflection. This sun rays would get reflected. So reflection would take place. So basically, now this will get reflected. Now again at the edge of B, refraction will take place. So what is happening? The sunlight is falling on the raindrop. Refraction and reflection will take place. This leads to formation of rainbow. Okay, and how we see rainbow? On the top is red and on the bottom is violet. And order is Vibgyor. Do remember this thing. And this medium where refraction and reflection is taking place, it can be anything: waterfall, sea spray, fogs. Right? And do remember, UPSC had asked question in sea spray. It has presence of dimethyl sulfide. So in environment, UPSC had asked ocean acidification is affecting the cloud formation. So basically, dimethyl sulfide is responsible for formation of rainfall. Just keep this thing in mind. Right? So basically, this acts as the nuclei, cloud condensation nuclei. And it can also help us in removing the pollutants from the air. But what is happening in ocean acidification? There is a less release of dimethyl sulfide, so it affects the formation of clouds. So do keep this thing in mind. Alright. So let's have a look at the one practice question on rainbow. Okay. I'll give you again 10 seconds. Or you can just pause the video and please solve this question. Alright, so let's have a look at the question. Refraction of light, simply bending of light when light enters into another density medium. Simple definition. So because of this, what all phenomena is occurring? Formation of rainbow, yes. White color of clouds, blue color of sky, no. They occur due to diffraction. Sorry, not diffraction, scattering of light. Right? So answer is just one. A is correct. A is the answer. So what all are the examples of refraction? Rainbows. You might have seen swimming pool look shallower than it actually is. Mirage on the roads. Then example of scattering of light. Blue color of the sky, red sky during sunset or sunrise, white color of clouds, Tyndall effect. All these are examples of scattering of light. Alright. So next topic is Bridgmanite. So recently, what scientists have done, they have studied the mineral named Bridgmanite. And because of this, they have found that inside the earth, there is a heat trapped. So that is dissipating sooner. So this is resulting into cooling down of the earth. Right? So, and cooling of earth is taking place at the faster pace. Alright. So now first question arises, what is Bridgmanite? Bridgmanite basically, this is interior of the earth. So we know we divided into different layers: core, mantle, and on top we have crust. So Bridgmanite basically materials, they are basically found where? In the lower mantle part. So between mantle, upper mantle and outer core. So there is lower mantle. So around 70% of lower mantle, it composes of what? Bridgmanite. And they are also known as silicate, perovskite, magnesium silicate, calcium silicate mineral. And these minerals were first discovered where? In the Ural Mountains. They are in the Russia. Just keep this thing in mind. Alright. So Bridgmanite consists of what? Magnesium, iron, calcium, aluminium oxide. And it has what? Perovskite structure. Perovskite structure क्या होता है? Basically it is in the form of ABX3. A is the metal cation which could be magnesium, calcium. B is also a metal which could be silicon or aluminium. X is oxygen. So 3 atoms of oxygen, O3. So this is the structure. So this is structure known as perovskite structure. Alright. So what was the study done basically? Study was that Earth is losing its heat at very fast pace than it was expected. So now, in the Earth we know how Earth was formed. Suppose this is the Earth. There was volcanic eruption, magma came out, and magma started cooling down at the surface of the Earth. So this led to the formation of what? Outer crust of the Earth. Right? Now since outer crust was formed, now inside the Earth some inner heat is trapped. So that is thermal energy, and that energy is responsible for various activities like plate tectonics, earthquakes, volcanism. This thing you need to remember. And we know various heat conduction mechanism. One of the heat conduction mechanism is radiative thermal conductivity, where thermal conductivity is through radiations. And it depends on what? Color of the object, opaqueness of the object. Alright. So what was the study done? We know what was the output, but how study was done? We did the optical absorption measurement. So at what rate? Basically, Bridgmanite material is absorbing the heat, thermal conductivity of the heat. So we found that Bridgmanite was absorbing the heat, or you can say thermal conductivity of Bridgmanite was 1.5 times than what was actually expected. So according to it, so this led to the conclusion that Earth is losing heat at very fast pace. So also what we have found that other rocky planets like Earth, like Mercury, Mars, Venus, they are also cooling at very fast pace, and very soon they would become inactive. Because if there is a sun has heat, that is why it is glowing. But Earth is not glowing. Why? It has already lost heat. So only little amount of heat is left. If that is also lost, Earth won't glow. And if inner heat is lost, there won't be any tectonic activities like earthquake, volcanism, plate tectonics. And also it is very challenging at what pace cooling is taking place. Right? Alright. So Bridgmanite basically we have found in India also. There were meteor showers in Nagpur. Just remember 2012, not 2022. They were collectively more than 30 meteors came. They are collectively known as Katol meteorites. What are meteorites? Meteorites are the meteors that reach the Earth's surface. And through these Katol meteorites, we found out that Bridgmanite are formed during later stages of the Earth's creation, not in the initial stages, later stages. And under what is the rate of pressure required? Pressure required is ranging from 23 to 25 gigapascals. So this is all about Bridgmanite that we need to study about. Alright. So next topic is Western disturbances. We know Western disturbances, they occur in India during winter's time. During the period of November onwards, it starts, intensity increase in December, then Jan, Feb, and then in March, April, intensity is very less. So peak time is January, February, March. Alright. So what is Western disturbances? They are bringing rainfall to the north and central parts of India. Alright. So it is an extratropical storm. Extratropical means type of a temperate storm occurring in the temperate regions. Right? It originates in Mediterranean region, and they are brought into Indian subcontinent by subtropical jet streams, and they cause winter rainfall. So they are mainly non-monsoonal precipitation. Alright. Driven by the westerlies and the subtropical jet streams. Alright. And their direction is from west to east direction. So they move in this direction. This is India, and they are coming from west to east direction. West to east. Alright. So basically difference between extratropical storms and tropical, we have extratropical storms, they carry moisture in upper atmosphere. But when it comes to tropical storms, they carry moisture in the lower atmosphere. Alright. So when these storms are coming and when they encounter Himalayas, they are pushed upwards due to adiabatic cooling. What would happen? Temperature will decline, condensation will take place and it leads to formation of rain. And if temperature is less than 0 degree, it will cause snowfall. And they are more frequent and strong in winter period. Alright, so what is the impact? When it comes, it brings moderate to heavy rainfall in the low-lying areas, that means plain areas, snowfall in mountainous areas. And which all parts of India? In the northern region and central parts of India, and sometimes it may reach the northeast, especially Assam region, but main focus is northern India and central India. Alright, and they cause most winter and pre-monsoon seasonal rainfall, just remember. Alright, and they are very important for the agriculture purpose, especially rabi crops. Rabi crops includes wheat. Okay, so our next topic is now Karewas. What are Karewas? Recently, why it was in news? It was in news because Karewas are being destroyed, because they are being used for the various purposes, agriculture purpose or construction purpose. So question arises, what are Karewas? See, Karewas are the lacustrine deposits, lake deposits. Basically, how they are formed? They are mainly found in the Kashmir region. So Pir Panjal range was formed. So water was flowing. Now, since water was flowing earlier, but mountain formed and they formed as a barrier, so there was accumulation of water behind. So it formed the lake. Now lake was carrying sediments, so it led to the deposition of sediments on the floor. You can say sediments. Now what happened? Due to continuous movement of water, it led to the formation of gorges in the mountain ranges. Valley was formed. So through these gorges, water got drained, and ultimately what was left behind? Sediments. So these sediments are known as lacustrine deposits, or we call them as Karewas, and they are found between Valley of Kashmir and Bhadarwah Valley. They are flat top mounds. Right? Just keep this thing in mind. Here is the region, Karewa formation. Okay, so they were formed during Pleistocene period. Rise of Pir Panjal, drainage was impounded, lake was formed. Ultimately, lake got drained through Baramulla Gorge, and deposits were left. And ultimately, they were known as Karewas. So, what are the significance of Karewas? First of all, they are alluvial soil, so they are fertile soils, and they contain sediments like sandstone and mudstone. They are very important for the cultivation of saffron, almonds, apples, several other cash crops. And Kashmir saffron is important. They have got geographical indication tags, GI tags. And what are the characteristics? You need to remember, they are longer and thicker stigmas, deep red color, they have high aroma and bitter flavor. And they are grown in what? In Karewa soils. But now what is happening? These Karewas are being used for construction and they are being exploited. So this is leading to destruction of the Karewas. Alright, so let's solve one practice question. I'll give you 10 seconds again. Please pause the video and solve this question. Okay, it is a simple question. What is it saying? Consider the following events in the formation of Karewas: formation of lake, deposition of clay, draining of lake, formation of gorge. We have just seen what is happening first. Formation of lake, mountain forms, lake is formed, deposition of clay takes place, second step. Then gorge form होगा, fourth, 1, 2, 4, and then draining of the lake, third. So answer would be 1, 2, 4, 3. C is the answer. I hope you all got the right answer. C is the answer. Alright. So now next topic is long period average. What is long period average? Recently, monsoon prediction was done by the IMD, Indian Meteorological Department. It gave the first long range forecast for this year, and it said that India would be having normal monsoon, that too for the 4th consecutive year. Do remember this thing. UPSC can ask for the how many consecutive years India has been experiencing normal monsoon. Okay, so now question arises, what is long period average? So long period average, basically what IMD did, it collected data for last 30 to 50 years and it calculated in every month what was the amount of rainfall, and also it calculated annual rainfall, and it took the average of those, right? So on the basis of that, it found a normal value, that every year this is the normal amount of rainfall that would occur. If it is less than that, it would be below normal. If above rainfall occurs below this normal value, above this normal value, it would be above normal category. So basically IMD predicts normal, below normal, above normal values based on this long period average. Alright, and long period average is calculated for what? We calculate for whole nation, for region wise also, and season wise also, month wise and annual wise. Okay, why we are calculating long period average? Because what is happening if we consider, suppose this is 2023, if we consider 22 as a normal value, but what may happen, it may have experienced some extreme event like El Nino, La Nina, drought year, or some heavy rainfall due to any other reason, or cyclone came. So that would affect the value of the rainfall. In 2021, it was normal rainfall, but still there was no extreme events. In 2020, it was the less than normal. 2019, whatever is the value. So now it becomes very difficult to determine what is the normal value. Shall we consider normal value during extreme events or without events? So what was the best way we found out? Let's take the value of last 50 years. On the basis of that, average will, because that will nullify whether it had extreme event or not. Right? Okay, so this is all about long period average. So basically this was used to do the long range forecast for this year. Alright, our next topic is Aurora. So what are Aurora? It is an optical phenomena, and it was observed in Iceland after a dead sunspot erupted. Alright, so now question rises, sunspot, these are the dark spots on the suns which increases the intensity of the sun winds, or you can say solar winds. And what are solar winds? They are in the plasma state. That means they are normal winds, but they carry electrical charge. So these are electrically charged winds, solar winds. Okay, so now what is the important role played by the solar winds in the formation of aurora? So first of all, aurora, they are formed in the high latitude regions. This is Earth, high latitudes beyond Arctic Circle and Antarctic Circle, right? North Pole region and South Pole region. In the North Pole region, aurora that is forming, they are known as aurora borealis. And in the south, they are known as aurora australis. Remember, in the south we have Australia, so on the basis of that we have aurora australis. Alright, so how solar winds leads to the formation of the aurora phenomena? We know this is Earth, it is surrounded by the magnetosphere. This is Sun, there is solar winds. So what is happening? This magnetosphere that is surrounding the Earth, it is protecting Earth from this impact of the solar winds. But if we look at the solar winds, magnetosphere, along the northern latitudes or southern latitudes, North Pole, South Pole region, there is a gap. You can see this gap. So through this gap, solar winds are entering. And when they enter, what they encounter? Remember structure of the atmosphere: troposphere, stratosphere, mesosphere, thermosphere or ionosphere. So when solar winds are entering, they will first encounter topmost layer, thermosphere, ionosphere. So in ionosphere we have ions particles, or you can say we have molecules of oxygen. So now these oxygen molecules will interact with the solar winds. Now solar winds are carrying energy, electrical charge. So now in case of oxygen atom, this is nucleus, and electron is orbiting around the nucleus. But when oxygen atom molecule will interact with the solar winds, energy would be transmitted to oxygen atom. So what would happen? This electron will move and start rotating around the nucleus in the higher orbits. But after some time, to achieve the equilibrium situation, it will come back, and when it comes back, it releases photons, and these photons are seen in the form of colorful lights. So this is how aurora phenomena is taking place, right? And what is the impact of aurora phenomena? They affect the communication lines, radio lines, and power lines, and sun's energies behind all this, basically solar winds. I hope you have got the basic idea what is aurora phenomena. All right. Okay. Our next topic is slow earthquake waves. Recently, what has been found, scientists recovered that below the Hawaiian island, the rock has been found. Below 3000 kilometer, a rock has been found, and if sometimes nearby to it, earthquake takes place. What is happening? Earthquake waves moves at fast pace, but when it reaches this rock region, which has been found in Hawaiian region, this slows down the pace of the earthquake waves. So this has been found, and it has been published in Nature Communications. And decrease in speed of the earthquake wave has been found is 40% slower than the surrounding regions. Okay. So what are these regions where this slowing down of earthquake waves are taking place? So these are the ultra low velocity zones. So it is believed, this according to scientists, that 4 billion years ago, we know Earth formed around 4.6 billion years ago. So around 4 billion years ago, Mars-sized rock crashed onto the Earth, and this led to the increase in planet's temperature. So melting of rocks took place, and it led to the formation of magma ocean. And after some time, what happened? Iron materials started descending deep into the interiors of the Earth, and this magma after some time solidified, and it led to the formation of the huge rocks. Now, due to presence of this iron content in these rocks, what we have found, this dense iron content is responsible for the slowing down of earthquake waves. So this is you need to know about. That is it. So basically, Hawaiian region, 3000 kilometer below, we found a rock. That rock has huge iron content that is responsible for the slowing down of earthquake waves. That is it. All right. Next topic is La Nina. So this is an atmospheric phenomena, right? Basically, better term would be it is an ocean atmospheric phenomena. Don't just say atmospheric phenomena. In this, UPSC can trap you. Just keep this in mind. Okay. So how La Nina is being formed? Simply, you need to remember it is also known as little girl. All right. And recently, what has been said that it is a friend of India. All right. Let's have a look at. North America, South America, Australia, Asia, Europe, Africa. So if we draw a line, this is equator. So in the equator region, what is happening? We know over here there is a flow of cold current which is known as Humboldt or Peru current, right? We find counter equatorial current, north equatorial current, south equatorial current, Australian current, west wind drift. So this is a scenario. So now what is happening in this region during La Nina period? This Humboldt current, it will extend in the eastern Pacific region. This will extend and it will enter into areas of the counter equatorial region or central Pacific region. So in this region we'll find cold water, extension of the cold water. So this phenomenon leads to the La Nina. So now what would happen? This is the oceanic phenomena. Ocean currents are swinging. While in case of atmospheric phenomena, what is happening? Descending of the air in the eastern Pacific. Winds are blowing in this direction. Over the Australia, we find convection current which is rising. So we find local level. Convection cell, which is interacting with what? Ocean currents. So that is why it is known as ocean atmospheric interaction phenomenon. At the ocean level, ocean currents, and atmospheric level, local convection current. Now, what would be the impact? Now, if you look at in the South America region, or you can say Eastern Pacific region, there is a descending of the air. Descending of the air, it will lead to no precipitation region. No precipitation. So, in the western part of the South America, in the Peru equator, we experience droughts. In the Australian part, what we are observing, rising of the air, they will rise adiabatic cooling, condensation. So this leads to formation of rainfall. So Australia will experience heavy rainfall. Right? So this is the scenario. And what we have seen, La Nina is positive linked with the Indian monsoon, and this leads to rainfall above normal or monsoon above normal. So it's a positive link. This thing you have to remember. I hope La Nina clear. Alright. So now what we need to remember is difference between El Nino and La Nina. In case of La Nina, what was happening? That eastern part of the ocean, eastern part of the Pacific Ocean, there was extension of the cold ocean current. But in case of El Nino, what is happening? This counter-equatorial will enter into areas of the eastern part of the Pacific Ocean. So area of the cold water will decrease. So that is El Nino. So this thing you need to remember. So in case of La Nina, water in the eastern Pacific would be colder. El Nino, water would be warmer. Alright. So this is a previous year question 2011. Let's solve the question. I'll pause the video. Alright, let's solve the question. What is it saying? La Nina is suspected to have caused recent floods in Australia. How is it La Nina different from El Nino? Okay, La Nina is characterized by unusually cold ocean temperature. We know it is true. In equatorial Indian Ocean, no. Equatorial Pacific Ocean. Whereas El Nino is characterized by unusually warm ocean temperature in equatorial Pacific Ocean. You need to remember, this is Indian, not Pacific. Just UPSC changed the simple keyword and it made the option incorrect. So first option is incorrect. El Nino has adverse effect on southwest monsoon. La Nina has no effect. This is also wrong because El Nino has adverse effect. That is true. But La Nina has positive impact. So it won't be no effect. So this is also wrong. So answer would be T. You just need to remember the every option very carefully. Alright. So next topic is avulsion in rivers. So recently what was found, the rivers in tropical and desert regions, they are more likely to change direction, right? And direction changes why? Because of avulsion phenomena. What is simply avulsion? Suppose a river is flowing. This is river. Around it there is flood bank, floodplains, river banks and floodplains. So now what would happen when river is full during flood situation? What would happen? There was spilling of water and water will end into floodplains if river is there and floodplains. So those river water will enter floodplains. It will lead to formation of new valley region. So now ultimately in future what would happen? If water is flowing, some water will move in straight direction, some water will enter into this region. So this is known as avulsion. So basically what is happening? Due to flood, water will cut off the land or river will start changing its course. That is simple avulsion phenomena. And because of this avulsion phenomena, what is happening? Water is entering into new areas and this is leading to flood in the new areas. These are rare phenomena. They occur only once a decade. Just remember this. They occur infrequently, not frequently. Alright. So what has been found in these studies? That where maximum avulsion is taking place. So if river is moving from mountains source to mouth is where river meets ocean, right? Source mountain, it is moving. So when river enters from mountains to plain areas, that means at foothills. So at foothills this avulsion phenomena take place, and secondly at the mouth of the ocean where deltas are formed. So we have found where best example is Kosi River. It forms at foothills of the mountains. Other near deltas example could be Orinoco, Yellow River, Nile River, Mississippi rivers. They are all forming where near low sloping deltas avulsion phenomena is taking place. Kosi River system, because this is the Indian river and UPSC every time asks questions on this. So Kosi River system, it flows through three regions: Tibet, Nepal and India. Major tributaries: San Kosi, Arun and Tamur Kosi. Just remember these things. And it is a tributary of Ganga, and it meets Ganga where near Kursela in Katihar district in Bihar. Okay. And Kosi carries maximum amount of silt and sand after Brahmaputra in India. This you have to remember. This is a very important fact. And it is also known as Source of Bihar because we know through avulsion phenomena, whatever water is entering into new areas in the floodplain areas, and it will cause floods. So likewise, through avulsion phenomena, Kosi River has been entering into new areas of the Bihar and causing floods and destroying the fertile agricultural lands, also disturbing the rural economy. Alright. So next topic we have Atlantification. What it says, Atlantic Ocean. So see, whatever condition is happening in Atlantic Ocean is happening in another region also. So on the basis of that, we have coined the term Atlantification. So what has been found that according to study, that parts of the Arctic region near Norway region. This is Norway, Sweden, Finland. So Norwegian Sea, over here we have Arctic Ocean. So in the parts of the Arctic Ocean, what we are observing same phenomena as we are observing in Atlantic Ocean. Atlantic Ocean is warm, so Arctic Ocean is also getting warm. Alright. So how it is getting warm? It is through Barents Sea. So where Barents Sea is located, we need to first get an idea. Barents Sea is over here. In the west, it has Norwegian Sea, Greenland Sea, right? Arctic Ocean in the north, and we have Kara Sea in the east. So do remember the oceans, water bodies surrounding the Barents Sea. Alright, and Barents Sea is shared between Norway and Russia region. Just keep in mind, as per the United Nations Convention on the Law of Sea. Okay, so now question arises, what is Atlantification? Dekho, what is happening? Over here we have Barents Sea, over here we have Arctic, and over we have Atlantic Ocean. So now we know from the map of the ocean currents, around equator we have north equatorial current, it gets reflected. So there is genesis of warm ocean current known as Gulf Stream, and further due to Coriolis force it reflects North Atlantic drift. So this warm water enters into Barents Sea. So now how this warm water is entering? This is, suppose this is ocean water, and if you observe from surface to depth region, so what we are observing, that warm ocean current through North Atlantic drift, it is entering Barents Sea but at the deep flow, as a subsurface current, not as a surface current. So now what is happening? Through subsurface, we have an Arctic Ocean, on the top we have ice. Through subsurface via Barents Sea, warm water is entering into Arctic Ocean. So below, in the lower bottom, what we have warm water, right? So this warm water is leading to melting of the ice formed on the Arctic Ocean. And also at the same time, what is happening? Global phenomena is taking place, global warming. So sunlight is melting ice from the top. So sunlight is from the top, it is melting the ice, from the below warm water. So this is the phenomenon of Atlantification, right? Okay, so basically ice is now getting hit both from top by a warming atmosphere and at the bottom by a warming ocean. Just keep this thing in mind. Okay, so what are the reasons for Atlantification? Simply global climate change. It is a universal cause, right? And what is happening? Arctic sea ice is melting at very fast pace because of this. Okay. And what is the impact of the importance of the Arctic Ocean? Ocean circulation. UPSC had asked question in the past, water masses, thermohaline circulation, this is getting affected. Then also it will affect the weather pattern, cyclone, tropical storms, intensity, frequency, jet streams and all. It is affecting environmentally Arctic ecosystem, because if water gets warmed, then organisms living in the Arctic Ocean, they have low tolerance level and they will get affected. So it will affect the food chain. UPSC had asked question in the past. Arctic Ocean is important region. So they had asked question in mains especially, that due to melting of the Arctic Ocean, what would be impact on the mid latitude climate. Also in Arctic Ocean is getting melted, so importance of Arctic Council is rising. So in the IR part they have asked this question. Just keep this thing in mind. Alright. So next question, what is supermoon? So recently strawberry supermoon was seen. So first let's have a look at the definition of supermoon, then we'll see why it is known as strawberry supermoon. Now see, we have a earth, we know moon revolves around the earth, right? And it has an elliptical orbit. So earth is sitting at the one of the center of the elliptical orbit. So if we draw a line and we have 2 points B and A, so what we have, distance between A and earth and B would be, suppose we consider at maximum distance, in between A and earth would be minimum. So minimum distance is known as perigee, maximum is known as apogee. So at perigee position, what is happening, if moon is at perigee position and situation is of full moon, Purnima, then we call that moon as supermoon. And why it is known as strawberry? Because according to Western people, when this supermoon occurs, there is a indication of that ripening of strawberries will take place, and also other fruits. That's why it is known as strawberry supermoon. Just keep this thing in mind. Alright. And how many days does moon takes to revolve around the earth? 27 days. And about this supermoon, usually what happens, it occurs consecutively. Just keep this in mind. It occurs consecutively and it happens 3 to 4 times. Basically when this is earth, moon, so basically in the nearby regions, not just exact position of perigee, but nearby to perigee position also, if the moon turns into full moon. So what would happen from the sorry, nearby to perigee position itself, supermoon would happen consecutively for 3 to 4 times within a year itself. Just keep this thing in mind. And who coined the term of the supermoon? Astrologer Richard Nolle. Alright. Next topic is Theri Desert. So basically recently there has been a lot of debate on this formation of the Theri Desert. So out of all the debates, one of the most plausible or reasonable cause that has been identified is that Theri Desert has been formed due to roll of southwest monsoonal winds. So now question rises, what is Theri Desert? So we have India. In India, we have state of Tamil Nadu. In this we find a desert, tiny desert, which is known as Theri Desert, right? And it consists of red dunes. We have sand dunes, so it has red soil. Because of that, it has sand dunes. And this Theri Desert, it is located where? In the Thoothukudi area. And we know from our current affairs that Thoothukudi area is also known for that ISRO is trying to launch its second satellite launch pad, where Thoothukudi region. And red sands are known as Theri. Just keep this thing in mind. And they are composed of sediments which were deposited during Quaternary period. And also it has marine deposits. Keep this in mind. Quaternary period, marine deposits. Alright. So since it is a desert area, so size of sands would be large. So obviously it won't be able to retain water because water will move down. And also it won't be able to retain nutrients. So they are water deficient and nutrient deficient. And aerodynamic lift is seen. Suppose wind is blowing, what would happen? It will uplift and carry these soil particles, and ultimately it will lead to formation of heaps of sands, which are known as sand dunes. In future, what would happen? Again, sand dunes, soil particle would be uplifted and it would be deposited here. So that's why it is known as, aerodynamic lift is observed. Alright. So now, Theri Desert, red sands, we find some minerals. Heavy and light minerals, you need to remember all these minerals because UPSC can ask which all minerals are being found in the Theri deserts or red sands. Ilmenite, magnetite, rutile, garnet, zircon, dipsite, tourmaline, hematite, goethite, kyanite, quartz, feldspar, biotite. Just remember all these things. And in case of iron-rich heavy minerals like ilmenite, magnetite, garnet, hypersthene, rutile, they all have undergone leaching by surface water. What is leaching? Where water-soluble minerals move downsides, right, in this soil profile. And these minerals are oxidized because of favorable semi-arid climatic conditions. Alright. Theri Desert, what is our features or how did they form? It is an undulating terrain. It looks like this, undulating terrain. It has presence of limestone. How? It indicates marine transgression because limestone would undergo decomposition and it will form the caves and all. So it indicates limestones, rocks were present, water entered and led to formation of caves. So it indicates marine transgression. Just keep this thing in mind. And how they have been formed, because ultimately question is this only. Debate was happening how they were formed. So now what happened in the Tamil Nadu region? We have Tamil Nadu region over here. We have Western Ghats. Western Ghats, Tamil Nadu. So what happened in the past? First, there was marine transgression. Marine water entered. Ultimately, marine water entered. It led to a deposition of sands. But then after some time, what happened? This water moved back, regression of the sea. So sands were left, first of all. Then winds are coming, monsoon winds. They rise on the western slopes, the western Ghats, and they descend from the eastern slopes. And as they were moving, what they did, they picked up these sands which were deposited by the marine water, and this led to the accumulation of sand dunes. So this is how it led to the formation of Theri Desert. So monsoon winds play important role. Just keep this thing in mind. Okay, our next topic is Karakoram Anomaly. What do you mean by Karakoram Anomaly? Recently study was conducted. It said glaciers in the Karakoram range of Central and South Asia, they have not been affected by climate change. That was the news. So basically, instead of melting of glaciers, what we are observing, increase in the size of the glaciers or same size. So this is the Karakoram Anomaly. So stability or anomalous growth of glaciers in the central Karakoram regions rather than retreat of glaciers, which we are observing in the mountain ranges of Himalayas. Alright, so now why Karakoram Anomaly has been seen? Why there has been no melting of glaciers? Simple reason has been western disturbances. We just saw earlier, western disturbances come during winters. It leads to formation of what? Heavy snowfall. So it is causing snowfall in the Himalayan regions. So thus it leads to increase in the size of the glaciers. So this is Karakoram Anomaly and associated with the western disturbances. Right? Alright. So now question UPSC may ask from the geographical angle, Karakoram range कहाँ located है? So if this is Jammu and Kashmir, on the top of the Jammu Kashmir we have Karakoram range, and it is surrounded by Hindu Kush mountain in the west, Pamir Knot. To the northwest we have Kunlun mountains which are running into China in the northeast, and Himalayas to the south, Himalayan ranges, southeast you can say. So these are the Karakoram range location, and it is spread over which all countries? Afghanistan, China, India, Pakistan, Tajikistan. Alright. Okay, so our next topic is Azores High. So what do we mean by Azores High? Okay, so why we are studying it? According to study, what has been revealed, that Azores High is resulting into abnormally dry condition where in the western parts of the Mediterranean region, which includes Iberian Peninsula, Spain and Portugal. So we know this is Mediterranean region. Over here we have Iberian Peninsula, Spain and Portugal. Alright. This is equator. This is 30-degree latitude. So along the 30-degree latitude, what is we are observing? Formation of subtropical high pressure belt. And we know this high pressure belt, it is not continuous, rather it is broken into cells. So on the western part of the Europe, we have one high, Azores High. So because of Azores High, what we are observing? Subsidence of air. So this leads to dry condition in the Iberian Peninsula. This is the news. This was the news basically. Right? So they are associated, Azores High are associated with subsidence of winds and the cyclonic winds. So they prevent the rise of the convective currents, and convective currents are essential for the formation of rains. Alright. So impact of the Azores High, annual drying of the Iberian Peninsula. Rainfall कम हो रही है, winter precipitation fall हो रही है, and ultimately if there would be less rainfall, it would affect the agriculture. Right? Alright. Okay, so next topic is Pileus Clouds. So recently in the Haiku city of the China, people saw a beautiful colorful shaped cloud, which is known as Pileus Cloud. So some people thought that it was a rainbow, but it was not a rainbow, rather it was a Pileus Cloud. So now question rises, rainbow we have already seen, what is it? So what is Pileus Clouds? So basically on top of a cloud, there's another clouds is forming. So they are known as Pileus Clouds. It's like accessories. We have various accessories on our head. On our head we wear an accessory like cap. It's like that. Instead of our head, it is a cloud. What kind of cloud? Cumuliform. Basically, it is a collective term for all cumulus clouds. Cumuliform clouds. Right? And cumulus clouds are what? Cotton-shaped clouds. Okay. So these are what? Accessory clouds. And they look like cap clouds. Cap clouds means cap of a cloud. Or scarf cloud means scarf of a cloud. So accessory for a cloud. And they look like a rainbow, but they are not rainbow. Right? So they are accessory clouds of a small horizontal extent, and they are part of a cumuliform clouds, as I already said. So how they are formed? Basically what is happening, suppose this is a cumulus cloud. Alright. On the top of the cumulus clouds we have cold air, and we find rise of convective current. Warm air is rising. So as warm air is rising, it will penetrate the cumulus clouds and it will rise further upwards. As it will enter into the region of the cold air, warm air will cool down, condensation will take place, and it leads to the formation of the Pileus clouds. So this is first clouds are forming. But now question arises, why they look colorful? So now in the clouds there would be presence of ice crystals and water crystals, and due to diffraction phenomena, sunlight will fall on those ice crystals. Diffraction phenomena means splitting of ice into colorful spectrum, those vapor. White light splits into these colors. So that is why what is happening in the ice crystals of the Pileus clouds, sunlight will split up and leads to formation of rainbow like colors in the Pileus clouds, and it lasts only for few minutes and hours, not for a long time, not for a whole day. Just keep this thing in mind. And later on what would happen, why it exists for only few minutes? Because it is absorbed by the lower cloud itself, lower cumulus cloud. Right? So usually it is not a very common phenomena, but what scientists have identified that Pileus clouds could be formed when cumulus clouds will turn into thunderstorms. So during that transition period, Pileus clouds are formed. Okay. Then secondly, what you need to keep in mind, that optical phenomena are observed in two types of clouds, Pileus clouds, and we have another lenticular clouds. In both this we find optical phenomena like colorful clouds, but Pileus clouds are not lenticular clouds. Pileus clouds are like accessories to the cumuliform clouds. But lenticular clouds, they exist without cumulus clouds. So they don't need anything. They exist in standalone. It could be anything, one cloud. But about Pileus, you need first cumulus clouds, and on top of that, these clouds would form. Okay. So what are lenticular clouds? So if you look at this diagram, how we are seeing it is a UFO shaped, alien shapes. Then you find downwind, downslope, downwind hills. It is sloping downwind. This way they are formed. This way they are aligned. And they resemble lentils. Just keep this in mind. This is all you need to know about. And they are formed where? Troposphere. So I hope you have got the difference between Pileus and lenticular clouds. So let's have a look at, because earlier question had been asked on the clouds. So let's have a look at it. Again, take a pause the video and solve this question. Alright, so what it is saying, during a thunderstorm, thunder in the skies is produced by, simply thunderstorm and how thunder is being produced. Meeting of cumulus nimbus clouds in the sky? No. Lightning that separates nimbus clouds? No. Because in thunderstorm we have cumulonimbus clouds. So second option is automatically wrong. Violent upward movement of air and water particles? No. Simply how thundering is formed in the cumulonimbus clouds. Thunder is caused by what? Rapid expansion of the air. Basically, lightning occurs. Lightning results into production of the lot of heat. So this results into expansion of the air particles which are surrounding the lightning. And as air expands at very fast pace, this leads to what? Thundering. A noise is produced, which is known as thunder. Alright. So now we have next topic, Indian Ocean Dipole. Indian Ocean Dipole is very important. Recently, why was it in news? In 2022 we observed negative Indian Ocean Dipole. And because of this, what happened? In Australia, there was above average rainfall. So now question arises, what is Indian Ocean Dipole? Again, keep in mind, it is a it is basically study of sea surface temperature. And it involves both ocean and atmospheric phenomena. Like La Nina and El Nino. So let's have a look at it. Africa, India, Indonesia, Austria. This is equator. Alright. So along the equator, we are observing the sea surface temperature. So western part, eastern part. So Indian Ocean Dipole. What is it is basically difference between the sea surface temperature of western part of Indian Ocean and equatorial eastern part of the Indian Ocean. Okay. So we have two kind of positive and negative. So in case of positive, what we are observing, that on the western part it is a warm condition. There is rise of air moves horizontally and it subsides over Indian Ocean eastern part. So there is cold water in the eastern part, and again there is a horizontal movement of winds. So this is a phenomenon that is occurring. So in the western part we have warm, eastern part we have cold. In case of negative, what we are observing, it is a reverse phenomena. In the eastern part we'll have warm, in the west part we have cold. So in the eastern part, if we have warm, so basically what is happening, winds also get changed. In the eastern part we have rising up of winds. In the western part we have subsidence of wind. If air is rising, it has moisture, condensation would take place, clouds would form, rainfall would occur. So in the case of negative Indian Ocean Dipole, what we are observing, rainfall in the Australian region. This is what we have observed, negative Indian Ocean Dipole, rainfall in the Australian region. Got it? Alright. But in case of Indian negative भी देख लेते हैं. In case of negative, Australian part has rainfall. In the western part, what we are observing, dry condition. But when we have positive Indian Ocean Dipole, what would happen? air would be rising in the western part of the Indian Ocean and it would have warm water, so it leads to positive, or you can say it strengthens the monsoon rainfall. In case of eastern part, we have rainfall below normal value. Just keep this thing in mind. And it is associated with what? El Nino Southern Oscillation. And as I said, it is ocean atmospheric phenomena. It is linked with El Nino Southern Oscillation. How? Via extension of the Walker circulation and associated Indonesian through flow. Because tropical warm ocean water would be entering from Pacific to Indian Ocean. This would also affect the sea surface temperature of the Indian Ocean. And we have already seen climate of Australia. So positive, what we have in case of positive, we have warm in western part, cold in eastern part. So warm air is rising, that means rainfall will take place. And also if some wind is moving of the warm surface water, its water holding capacity would increase and it would cause more rainfall. Right? So, but over the eastern part we have less rainfall. And positive Indian Ocean dipole is linked with El Nino phenomena. Just keep this in mind. Alright, negative links, reverse situation, cold, warm. So warm in the eastern part, so we have more rainfall in eastern part, Australia part. When the western part we have dry condition. And they are mainly associated with what? La Nina phenomena. Alright, let's solve one question. Please pause the video and please solve this question. Alright, with reference to Indian Ocean dipole, what it is saying exactly. Indian Ocean dipole phenomenon is characterized by difference in sea surface temperature between tropical western Indian Ocean and tropical eastern Pacific Ocean. This is wrong because it is basically temperature between western Indian Ocean and eastern Indian Ocean. So just change of word. Instead of Pacific, we have Indian Ocean. You must have seen in the earlier question also, La Nina, El Nino. What UPSC did, it just changed the keyword. Instead of West Pacific Ocean, it mentioned the Indian Ocean. Same thing it has done in the Indian Ocean dipole. So you can see similar question had been asked by the UPSC earlier also. It's just repetition of question only. It just earlier it asked question on the El Nino, now it asked question on the Indian Ocean dipole. So see, there are repetition of questions also. Alright. So first is wrong. Second, IOD Indian Ocean dipole phenomena can influence El Nino's impact on the monsoon. This is correct. We have seen positive Indian Ocean dipole, it is linked with El Nino phenomena. We have already seen it. So yes, B is the answer. Alright. So now we have our last topic. So last topic is Dvorak Technique. So it recently American meteorologist Vernon Dvorak, who had actually developed this technique, Dvorak Technique, he passed away. Okay. So this technique was used to forecast weather. So basically what was the basic mechanism? Through satellite, images were collected, data was analyzed statistically through formulas, and it helped in estimating the what is the intensity of the tropical cyclone. Alright. It uses infrared and visible imagery in the satellite, and it is based on this. It is based on what? Cyclone's convective cloud pattern. Based on this, it is understanding what is the structure of the cyclone, where I is located, and it is able to estimate the intensity of the storm. So basically it gives the best estimate of the cyclone intensity. And if we are able to predict about the cyclone in better way, it will help us in issuing weather warning and also mitigate the impact of the cyclone disaster. So this is the benefit of the Dvorak technique. So recently new update of Dvorak technique has come. It is named as Advanced Dvorak Technique, ADT, and it has been coined by National Hurricane Center of the National Oceanic and Atmospheric Administration. So basically aim is Dvorak technique is to forecast about the tropical storms. Alright. Okay friends, I hope this session was helpful to all of you. To get the requisite materials for the UPSC and also about this session, please visit our Telegram channel. You can scan the QR code also, or name of our channel is OnlyIAS, nothing else. Definitely. We want nothing else. We just want OnlyIAS. Okay. Thank you.